Welcome back to Data-Driven Engineering. The very first thing that we need to do is install Python on your computer, and there are instructions here on how to do that for Windows, and then most likely it's already there for Mac or Linux, but you can get a different version, or make sure you have the right version installed. And then we're going to be talking about how to install these packages. Okay, so first of all, we're going to check to make sure we have the correct Python version. We know which one we're working with. And then we're going to add all of these additional packages that make it very useful. And then manage those as well with virtual environments or other ways if you have specific needs for the specific versions of those packages, for example. Okay, so I'm going to open up first of all. This is a command prompt. If you need help finding that, just come here and type cmd. Okay, and then type where Python, and it will show you where that is. You can also, if you have Python 3 installed, you can say, where is my Python 3? Now in Linux or MacOS, you can do the same thing, but it's just which Python. Or if you don't have Python, that's often Python 2, you need to do Python 3. It'll show you where you have it. That's your global or general Python installation. Sometimes you don't want to install in that environment, but you'll create a virtual environment. We'll show how to set that up as well. Okay, but in Windows, let's say I wanted not just that, the standard one that comes with Microsoft Windows, but I want to go maybe to Python download, okay, python.org, and grabbed the latest one. Now, some of the problem with installing the latest version of Python is that sometimes there are some packages that are not compatible with it. So if you have a package such as a machine learning or data science package that isn't compatible, then go back here to one of the earlier versions. Okay, so if you want to find a different version, you can come here to Windows and, for example, get one release back if you'd like, maybe Python 3.10. For example, which will maximize your compatibility. If you look at Anaconda, the download is actually 2 minor versions back. It's 3.9 right now, and they have many more packages they support, so they don't upgrade to the latest one until all of those are compatible. So if you want one with maximized compatibility, just go with an Anaconda download, but I'll show how to do it with others as well. Okay, and here you can see it's still 3.9. But if you want the latest one, definitely come here to python.org, and they'll encourage you to get the latest one because they're trying to test the new features and they want a user base that's going to be using that as well. All right, so I downloaded that, and here is my install now. Now, this is going to be an important directory that we're going to create. When we do virtual environments, we'll create our own directory. Okay, so I'm going to, instead of using this long directory, I'm going to customize that. All right, and then I like to change this, not into app data, which is this hidden folder, but I'm going to shorten that just a little bit and create my own folder there. And when it asks me if you have to have administrative privileges, you want to install it just for yourself, not for everybody on your computer. And that helps you so you can also install packages later. Okay, so there's 3.11, and we'll just see how well the packages here are going to line up and be compatible with this new version. Okay, so after that finishes installing, now when I come here and I look for, okay, and then I can say where Python, okay, it still has just the default one, even though setup was successful. I'll go and disable that, okay, and you can see that it can't find it. So the other thing you need to do for pip, because we're going to use pip package manager later, we need to make sure that the environment variables are set up. So if I just look up environment variables and edit these, I'm going to come here to this environment variables. I need to make sure that I've added that to my path. Okay, so I'm going to edit these in my path. I had an older version here, and now that is 3.11. Okay, so let me edit this one as well. You need both the base folder as well as the scripts folder. Okay, and then click OK. And then if you close that terminal and then open it again, and then you say where Python, then you'll see that one is going to show up. And so if I type Python, it's going to use that one first. So I have 3.11. That's the one that I wanted. Okay, so let's go ahead and go on to the next step now, okay, which is manage the Python environments. Now, this is very important, especially if you have the global Python environment. Maybe there's a version number of a package or something like that that's not compatible with all of your other projects, and maybe you have very specific version requirements. We're going to set up a Python environment, okay? And there are 3 ways to do that. Virtual environment, venv. That's the newer one that's built into Python. An older one, you'll see many of these instructions to pip install virtualenv. That's for older than Python 3.2 or older. Okay, but if you're on Python 3.3 plus, then just use this one. All right, so what we're going to do is if you have Python 3, that's great. In this case, I'm going to change to my desktop. All right, and then if I just do Python, I don't need Python 3 here because I'm on Windows, but if you're on Linux or macOS, you might need to do Python 3 there. Okay, and I'm going to do virtual environment, and I'm going to say that's going to be my project. And it's going to copy about 2,400 files in there. Okay, it's almost like a local version of Python. I'm going to delete that one. That's my install. Okay. And inside this is my virtual environment. It's like its own little Python installation with just the versions that I need. And you can see this activate right here. So I'm going to activate, okay, that virtual environment. So if I change directory, okay, into that new virtual environment, and then also change to the scripts, and then just type activate, then you can see I've activated this. You can see project here. So it's right now it is using this version of Python. And so if I, for example, pip install numpy, then it is going to collect that and install it just here within this project. Okay, and I can see site packages, I've got numpy there. All right, so that's a virtual environment. And you can also do that in Linux. And so if I do Python 3, and I'll create a new virtual environment, and I'll create a new project. Yeah, it takes a little bit to copy everything over. It's like a compact version of Python that you're having just for this. Okay, so if I go into project, then I can see here in the bin folder, that's where I have my activate. Okay, so if I do source, and then this one is, let me get back to the instructions here. If I do the environment name bin activate, so I go to that path. Okay, so project, and then I have bin and activate. Then you can see I now have this activated, so it's only going to install Python version, the packages that I need right here. So if I do pip install, and then let's say I do numpy, and I want 1.23.1, then I can get a specific version of that package. All right, and so this one is going to install it in that folder just with that very specific version that I needed. Now we're also going to maybe have a list of versions that you need. There's a very convenient way to do that with a requirements.txt file, and we'll show that a little bit later. Okay, so just make sure you activate it when you're done. On both of these, you can just say deactivate, and it goes back to your base Python that you were using. And if you're done with this and you don't need it anymore, then you can just delete that folder. Okay, and you say, can't delete it because I still have this open. I'll try again. That was 6,200 files that it just deleted there, okay, that were in that directory. All right, so you can activate or deactivate that virtual environment. Now, you can also use conda as well. Conda has, it's more than just Python. It has R, Python, other languages as well. So that's a great package manager to use if you're working outside of Python as well. All right, now let's get to installing Python packages. Once we have Python installed and set up, we can do that either through pip or conda package managers. I prefer to use pip. There are more packages that are available in pip. Conda has, like I mentioned, outside of Python, you can manage packages. So if you ever run into permission error, you just want to install it locally, you can just do the -- user. But first of all, let's just ensure that we have the latest version of pip. All right, so I'm going to do Python -m, and I'll do ensure pip, and I will upgrade it. Okay, so I want to ensure that it's there and it's already satisfied. All right, and if you just do ensure pip, it'll just check to make sure you have pip available. Okay, so there we have the latest version of pip. All right, so now we can install packages. All right, and I'll go through some of the packages that are useful here for working in data science. Like I mentioned before, you can add the version number if you do the double equal sign, and then you can specify the version that you want. And one of the nice things with pip is that it's also going to install all the dependencies as well. So if I leave off that version number, it's just going to go and get the latest one. So it said I don't have NumPy, so it's going to install NumPy and Gecko. All right, so as you go through this, you might see some extra packages that are installed, and it's going to take care of the dependencies for you if the person writing the package listed the dependencies. Now, if you, for some reason, you had, let's say you installed the wrong one, then you can just say uninstall, and it'll ask you if you want to remove it. All right, and then let's say you want to install a different version, and I'll do 1.0.3. Oh, it doesn't have that. I'll do 1.0.4, and it collected and installed that. And then you can always upgrade your package by doing -- upgrade. Okay, so it's going to remove the earlier version and then install the new version. Okay, so there is the the new package that is installed. Let's go through a couple of these. We can also install in Jupyter Notebook as well. So let's go to that one. I'm going to start a Jupyter Notebook. All right, I'll just go to desktop, and all right, so I can also go pip install and then the package name, and that can just be run right here from a cell. All right, now if you've installed something, if it installed it, you just need to come to kernel and then restart the kernel. Otherwise, it won't be able to find it, won't be able to use it. Now, if you're using Google Colab, it's taking care of that already, so you don't necessarily need to restart the kernel if you're working online. in a cloud-based solution such as Google Colab. All right, so there are the instructions. This is another way to do it if you just want to give somebody a script and then have it automatically install the package from the script, although this is not recommended. Okay, it can do things to your package management that make it difficult to manage packages later. So if you're writing a program, don't do this to somebody. Just give them a requirements file and they can choose to upgrade their packages or install them themselves. All right, the other thing we can do is pip list, and that will show all of the packages that are currently installed with their version numbers. All right, and that's very convenient, especially if you're trying to troubleshoot, something isn't working, you're looking for the latest version. All right, and there are a number of packages that we're going to talk about here, okay, in these different modules. Let me come back up here to the menu. We're going to go through basic Python, okay, including NumPy and Pandas. We're going to need to have those packages. And then we're going to be doing things like processing video, and this is going to be using OpenCV. We're going to be looking at sensors, okay, and MicroPython has just a subset of some of the packages that we need, or special versions that can run on these microcontrollers. All right, we're also going to be doing web scraping. So for example, with downloading URLs through Pandas, or we can use something called Beautiful Soup, okay, to process and do some web scraping. So we're going to need some of these packages for these applications. So if I come back here, okay, so this is a list of many of the packages that we're going to be using in this course. So let me just scroll down here again. Okay, Beautiful Soup is one that is for extracting web scraping. Okay, we're going to use Gecko as well for some of the linear models and system time series identification. All right, Matplotlib for data visualization. All right, NumPy is a very powerful base package that's used in many other packages for scientific computing. All right, OpenCV, that's a computer vision package originally developed from Intel Research, but is now open source. Okay, and Pandas it's essentially kind of like Excel, but can do many other things without having to have the GUI interface of Excel. There are many other functions and importing capabilities that you can use with Pandas. I like using Pandas for manipulating data. Okay, Pandas profiling helps give a detailed analysis of some of the data and some of the data exploration phases of working with data. Okay, Plotly is like Matplotlib, but it's a more modern version. It's interactive web plots. It can be HTML. It's HTML and JavaScript. Plotly Express is also included with Plotly. A little bit easier to use. Scikit-learn. This is a variety of classification, regression, clustering algorithms that we're going to use to just test out some of these algorithms, especially in the machine learning course that's going to follow this one. All right, SciPy. This one is a scientific Python package, extends the base capabilities of NumPy. Seaborn, similar to Plotly and Matplotlib, creates some very nice detailed plots with few lines of code. Stats models, very nice. I like this one for ordinary least squares. OLS model, there's others in there as well. Very nice statistics package. Okay, Temperature Control Lab or TC Lab. This is a nice one for working with this device or a simulated version of this device. Okay, we're going to use that for some exercise, especially in time series modeling. Okay, so that's quite a few different packages. Now, if you want to just give somebody a requirements.txt file, you can put in there the specific versions that you want them to install. And then they can just run pip install with a -r with requirements.txt. If it's in a different directory, you just put the path to the requirements file. So here are some of the files that we're going to be using for this course. Let's go ahead and just include those into a requirements file. All right, I'm just going to do requirements.txt and then open that up. All right, and I'll save it right here. All right, so I haven't tested this with Python 3.11, so there's a chance that some of these are not going to be compatible. Let's just go ahead and try it. We'll do pip and then install. All right, so we'll just see if it has a compatibility with all of these base packages. And so it's going to download those and then try to install those with their dependencies. Okay, so here's a deprecation warning. Sometimes you'll get some warnings. As long as it doesn't turn red, you're generally okay. It was able to download all of these pretty quickly. You do have some of these additional dependencies that we didn't specify there, like PySerial or Patsy or Tenacity 6 as well. So some of these are just ones that we didn't request, but they were dependencies of other packages that are there. All right, it'll take it just a little bit. It's going to install all of these. You can see quite a few of these packages, and just how large they are. Some of them are just a few, kilobytes. Beautiful Soup, for example. The LXML is a little bit larger. Looks like OpenCV Python 38.2 megabytes. You have SciPy 39 megabytes. Okay, stats models 9 megabytes. Okay, so it's working to install these. It's not just copying the files over. Some of them have a setup.py file that's running just to set up and compile some of the packages and convert it from source code down into compiled versions. Or, sometimes it takes the Python file and then is going to give a PYC, kind of a compiled Python file. So it's working through all of those right now. It's running the setup.py. Now, as long as it makes it through with no major errors, then we should be okay. Now, again, if you do see errors, then the easiest thing might be to go back and just go back to an earlier version. There are some sites out there that try to compile for the latest version as well, that you can go and download those wheel files from. Okay, if the PyPy version is not the latest one. All right, I'm just going to wait a little bit. I'm kind of waiting in suspense to see if it's going to complete successfully. If it does, then I'll keep Python 3.11. If not, I'll go back to Python 3.10. All right, and I guess just while this is going, let me give an overview of what we're going to be doing next in this course as well. So I'll just make this just a little bit larger. All right, and I'll come up here to the overview. Okay, so we had Python. There's an overview, install Python, install packages. That's the one we're working on right now. Then next, we're going to come to Python basics. All right, and there is a Colab notebook where we're going to just go through some of these basic exercises with Python. Looks like it just finished, and it looks like it is successful. All right, so there we have it, all the packages that installed. Okay, so I'll just go ahead and close that for now and finish this overview. So we'll go through basics, we'll go through tuples, lists, sets, dictionaries, NumPy, pandas, and then we're going to go through data access and talk about text files, audio files, video, databases, sensors, getting data from the web or cloud processing, and cloud services, and then web scraping. All right, and then data transfer as well, giving an overview with Modbus, MQTT, OPC UA, WebSockets. So how do you move data between computers and have them communicate in a way that creates responsive applications, and you're able to store data or retrieve that as needed. Also talk about time series data. With pandas, we'll talk about a couple of the time series models, ARX and state space. All right, and then there's another section on data engineering with gathering data, statistics, visualizing, cleansing your data, features, balance, scale, split, deploy. Okay, so some of the standard pipelines that you set up as you collect new data. You can go through these different data engineering steps to cleanse and prepare your data for things like machine learning. Then we have a few of these applications right here that talk about how to collect data and then process it. And we're going to be using some of these sensors like air pressure sensor, temperature sensor. There's also a time series modeling exercise as well. And I'll add additional applications here as well. All right, there are some related courses as well. Begin Python, MATLAB, Java. There's engineering, computing, data science, machine learning. There are some control courses in MATLAB and Python, optimization, and dynamic optimization as well. The next one after this course, maybe the best one, might be the data science or the machine learning. If you come here, you'll see the machine learning one. This prior course on data-driven engineering, it really talks about how to collect the data and manage it. And then machine learning then takes it from here with some of the data cleansing, the data engineering pipelines, and then when you actually get to the machine learning. All right, well, I hope you've enjoyed this overview of the courses and also how to just manage and install your packages in Python. Look forward to working with you throughout this course with additional content.